In today's video, we're going to walk through how you can get started with the ServiceStack OrmLite library. As a lightweight and powerful ORM, you can use it with any .NET application. OrmLite is a fast, easy to use ORM library that avoids the complexity of other larger ORMs while still providing loads of functionality with high performance. Throughout this tutorial, we'll demonstrate the best patterns to use when installing and configuring OrmLite in your .NET application, establishing connections to your database, defining models with OrmLite's code-first approach, and explore the core create, read, update, and delete operations. By focusing on these fundamentals, you will have the understanding and patterns you need to rapidly integrate your database with your next .NET application. So, what exactly is OrmLite? OrmLite is a lightweight object relational mapper. That is, it's a library that helps you integrate with a relational database like SQLite, Postgres, MySQL, and Microsoft SQL Server. It embraces a code-first model, enabling you to define your data structures in your code as classes and have your database tables generated from those models. OrmLite also supports a database-first model where you can reverse engineer your plain old CLR object classes from an existing database schema. OrmLite's key design philosophy is simplicity and minimalism, and this is reflected in its clean API and straightforward usage. It's designed to be fast, easy to use, and most importantly, unobtrusive. It works with your POCOs or plain old CLR object classes without any requirements for base classes or attribute decorations, although they can be used to configure your models further. And while OrmLite fits seamlessly into the wider ServiceStack framework, enabling high-level features like low-code, a web-based UI for managing your database, it's also designed to work with any .NET application independently. To start things off, let's have a look at how we can install and configure OrmLite to connect to a SQLite database from a console application. Firstly, we need to add the OrmLite library to our project. This can easily be done through the NuGet package manager. Just search for servicestack.ormlite.sqlite and install it. Now that we have OrmLite added to our project, the next step is to establish a connection to our SQLite database. We will need a connection string for this, and for simplicity, we'll connect to an in-memory SQLite database. Here we can see we're creating a connection factory, which is a way of generating database connections. When creating your new OrmLite connection factory, you need to pass it a string of your database connection string and the provider instance that you'll be using to connect to your database. The provider is what tells the OrmLite connection factory what technology of database that you'll be connecting to. In this tutorial, we'll be using SQLite, but OrmLite also supports Microsoft SQL Server, MySQL, and Postgres. Every time you need a new database connection to fetch something or update something in your database, you use the connection factory to create that new connection. It's important when creating a new database connection that it's only open for the minimum time required. That is, as soon as you're finished accessing your database, you want to dispose of that connection so it goes back into the pool of connections you can draw from. The easiest way to create a new connection and start using it is to use the method OpenDBConnection. Because we want to make sure our database connection is disposed of when we're not using it anymore, we can use the using statement before the variable declaration. Now we've seen how you would go about configuring OrmLite to be used in any .NET application. However, if you're using OrmLite with a new ServiceStack application, it's even easier to configure and get started. If you're creating a new project, ServiceStack provides a .NET tool called X, which you can use to set up a new project with a specific database connection quickly. Once you've created your new project using the xnew command and picked the template you need for your new application, you can use the command xmix. For example, to configure our SQLite connection, we can use the command xmix SQLite. This will automatically add the required NuGet dependencies to your application, creates a configure.db.cs file which contains the configuration for your OrmLite connection factory, and adds it to the ASP.NET services for dependency injection. And lastly, it adds a migrations folder in your app host project. This contains an example migration if you want to handle database migrations programmatically using the app tasks systems in the ServiceStack framework. To keep things simple for this tutorial, we will primarily show the use of OrmLite in a console application, as well as the most common way you will access your database connection in a ServiceStack service. Now that we've had an overview of the configuration of OrmLite, let's take a deeper look on how OrmLite interacts with your database. In this section, we're going to focus on the fundamental usage of OrmLite. Starting with your model classes, we will look at the use of naming conventions and attributes and how they translate when performing operations on your database. Next, we'll look at the basic create, read, update, and delete operations and how those operations map to basic SQL statements. When it comes to naming conventions on your database model classes, OrmLite by default maps the class and property names to the table and column names respectively. How these class names and property names map to the database for the table name and column name specifically is up to the provider being used with OrmLite. So in this case, we're using the SQLite provider. But if you are using the PostgreSQL provider, you have a different naming strategy which would change how those names map between your codebase and your database schema. If you're using OrmLite to create the tables for you, this isn't something you'll need to worry about. But if you have an existing database, this naming strategy by default might not map up to how you've named your tables and your columns. This is of course completely configurable and is based around sensible defaults for the backing database technology. Another convention that's used for OrmLite relates to primary keys. For example, if your model doesn't have a specific primary key that's specified using an attribute like auto increment or primary key, it assumes that a property named ID will be used as your primary key. And in terms of defining relationships between tables, we have a similar naming convention. Let's take, for instance, we have an order table and an order class for representing that table in code, as well as an order detail class and order detail table. By inserting an order ID property in the order detail class, we can set up the relationship between them. For explicitly specifying a foreign key relationship, we have the foreign key attribute just like we have the primary key attribute for specifying primary keys. For the foreign key attribute, we can use type of and order to relate the order details back to the order table. We can use the auto increment attribute on our primary keys to let our database handle the increment of sequences as we insert new data. In addition to attributes like primary key and auto increment, we can use the index attribute and apply them to our specific columns to manage our indexes. If you have a table with some columns where the naming of those columns doesn't comply with your naming strategy, you can use the alias attribute on specific properties to override that name. The alias attribute can also be applied to classes to override a table name. This can be handy, especially for columns that use acronyms or initialisms. Next, we have attributes like default, required, and string length, which are applied when making schema modifications. If we persist these changes to a SQLite database file and recreate our tables, we can see the schema reflects what we've done using our attributes. Next, let's look at the basic create, read, update, and delete operations when working with OrmLite. When you use the insert method of an IDB connection and pass in an instance of your model, OrmLite will perform the following SQL statement against your database. Everything is derived from your model class. If we want to get values out of that table, we specify our model type in the select method. Not specifying any arguments will perform a select all by default. If we want to perform an update to a row in our database, it's just like the insert method, but this time we call a method update, providing an instance of our model class. And here we need to ensure that the model class's primary key is populated with a value. This is because the update method needs to know which row to operate on. This requirement of having a value in your ID property is also applied to the delete method when we want to delete a specific row. And these are just the basic methods and operations we can perform using OrmLite. And all the OrmLite methods and operations all have an asynchronous counterpart using the async suffix. Now we have an understanding of the basic operation of OrmLite, let's look at some additional features and functions you can use to make your development easier. The load select method is a great feature that lets you automatically load related data from other tables with minimal code. To demonstrate this, let's add an order line model to our example. An order can have multiple order lines, each representing a new line item in an order. Here, the order ID property links an order line to its parent order, and the reference attribute on the order lines property in the order class tells OrmLite that these order lines need to be populated from a related table when the load select method is called. The order ID property on order line is following the naming convention of related table name with the ID suffix. And since the order class has the reference attribute with the matching type in its list, meaning that it is a one-to-many relationship, OrmLite knows to select that related data to populate the list of order lines. By calling the db.loadSelect method specifying the type of order, we're loading an order and all its associated order line objects in a single operation. OrmLite automatically generates the necessary SQL to fetch the related data related to our order. And when querying our data, we have several different methods to choose from when we're doing different types of operations. For example, we have a series of methods that start with the single prefix, like single, single by ID, and single where, which are convenient for fetching single records. Just like our select statement, the single method takes an expression that will help us generate our query. If we know the specific ID of the row that we want, we can use single by ID, specifying the type again and passing in that ID as the only argument. The single where method can be used if you don't want a strongly typed expression and instead just want to provide a single name and value pair. And if we want the functionality of the load methods with the single by ID method, we also have combination methods like load single by ID. A lot of these query methods also have quite a few overloads where you can choose different ways of querying your data. The SQL expression overloads gives you that type safety of C# while still working with your custom model classes, and you can build intuitive expressions that get translated into SQL statements. When building these expressions, we also have access to the static SQL class to help us work with native SQL features like in a SQL inquiry. And these SQL expressions don't have to just be produced within an easy-to-use Lambda expression. Instead, you can separate the creation of your query and the execution of your query to two separate steps. This gives you a lot more flexibility when creating your query in situations where you have conditional business logic. Instead of duplicating parts of the query for each condition when you execute it, You can create the query object at the start and apply different rules to the query based on those conditions. Another overload you'll find in all these different query methods is the ability to provide raw SQL with a variety of different options for specifying parameter values. This is ideal for situations where you want to leverage vendor-specific functionality so you can get the most performance out of your specific database. For example, if you are using Postgres with an extension like PostGIS and you wanted to use a specific index type that required to structure your query in a certain way, it would be best to use a raw SQL statement and let OrmLite map the results of that query back to your strongly typed model classes. So as we can see, OrmLite, while still being a lightweight ORM, still provides a rich set of features that can make it easy to perform your day-to-day database operations. The real power of OrmLite is that it keeps the simplicity and flexibility at its core. You can use type-safe, easy-to-read methods for your common operations, and if you ever need to, you can easily drop down to plain SQL. This combination allows you to handle complex scenarios without the complexity commonly associated with larger ORMs. And this focus on simplicity brings with it a whole range of higher level features that we've integrated directly into the wider ServiceStack framework. One of these key high level features that is powered by OrmLite is AutoQuery. AutoQuery is a dynamic query feature of ServiceStack that enables you to create and execute customizable queries from a URL that interact with your database model. This can be done in a strongly typed fashion by creating your database model up front, as well as related request DTOs, or you can use the Generate CRUD Services option in the AutoQuery feature plugin to let it do all the work for you by generating these API services directly off your database schema. By simply configuring AutoQuery in your app host, you instantly have a powerful query API that works with your existing database. No extra query methods to write and no SQL to manage. And when you're ready to move from a database first to a code first approach, you can use the ServiceStack.NET X tool to generate POCO model classes from your existing schema. These POCO classes can then be worked with directly using OrmLite, and the request and response DTOs that are also generated can be used to override service functionality just by writing a normal ServiceStack service. All these high-level features of ServiceStack, from AutoQuery to CRUD service generation, are powered by OrmLite. This means that OrmLite is a mature, battle-tested library that you can rely on for your data access needs. To quickly show an example of this working and how easy it is to get up and running, let's take the SQLite database from our previous examples in our console application and put it into a newly templated solution that we have created with the command xnewweb-myapp. This is a basic ServiceStack project that we're now going to add support for SQLite and AutoQuery. This can be done using the command xmix SQLite --autocrudgen. We can then update our connection string to use our imported existing database, and then we can run our application. We now have fully enabled CRUD services using AutoQuery, as well as low code to manage our data and API Explorer web UI to explore our APIs. We've really only scratched the surface of what you can do with OrmLite. We've explored the fundamentals of ServiceStack OrmLite and learned how to set it up and integrate it into our projects, as well as looking at a variety of ways to interact with your database and delved into some high-level features it enables when integrated with the wider ServiceStack framework. If you want to learn more about what you can do with ServiceStack OrmLite, check out the ServiceStack docs page. We also have some reference docs if you want to look at any specific API. If you want to see a deeper dive on any particular topic with OrmLite, let us know in the comments or join us in our Discord or GitHub discussions. And as always, thanks for watching.